Designing duct layouts, I'm going to make this super simple. I've got 4 steps in my workflow, and with each step, I'm going to give 3 really practical guidelines to follow. My first step is place air outlets and inlets. I start here because I don't need to know where my ductwork is going to be yet, and at least I know where I'm going. For guidelines on how to do diffuser placement, check out the video I posted on April 3rd. I'll provide a link below for that. My second step is to place the central equipment and lay out the mains. Guideline 2.1 is to keep it central and follow corridors. If this was a city and your duct were your roads, then your duct main is going to be like your freeway. You want it to be as central as possible. And a great way to do this is to follow the corridors. Below the ceiling, corridors are designed as an efficient path of travel for occupants, which coincidentally makes them an efficient path of travel for utilities above the ceiling. Guideline 2.2 is avoid no-fly zones. Some obvious no-fly zones include stairwells and elevator shafts. Some other spaces you want to avoid are electrical rooms and IT rooms. They've got enough going on in there, and there are codes about minimum clearance that can make things really messy if you try and run duct through there. So following these guidelines, I'm going to run my main ductwork right out here and straight up the corridor. Guideline 2.3 is simply don't get attached just yet. You can always make tweaks when you get to the third step, placing your terminals and connecting to your mains. Guideline 3.1 is to start near the zone that they're serving and try to forecast your branch ductwork. So if this is my zoning, I'm going to start by placing terminal units near each of the zones and also somewhat near the main. And then I'm going to envision what the branch ductwork is going to look like, how it might connect to the main and branch out to the diffusers, and I'll make a few adjustments to account for that. So here's an example. Down here, this position isn't going to work so great. So I'm going to move this VAV over here. I'm imagining that it's going to connect to my main somewhat like that, and then branch off and serve the diffuser somewhat like that. Guideline 3.2 is consider piping. Piping is more expensive than ductwork. So if I'm doing VAVs with a reheat coil, I like to put them in pairs if possible. This keeps the connection points for the pipe kind of grouped together and allows you to branch off once and hit 2 terminal units in one go, saving a lot of pipe length. It's also why I like keeping my terminal units in line. That way you can run a pipe main right over them, tap down, and really streamline your piping. Guideline 3.3 is consider maintenance. You want to try and place your equipment where it will be convenient for a facilities worker to access them. You'll notice I did not place any of these terminal units in the offices. If possible, it's better to place them in a transient space like a corridor. Also, you don't want to place equipment in restrooms, especially women's restrooms, where it's going to be inconvenient for someone to go in, pop a ceiling tile, and try and do work. Bonus points if your equipment shares access like this. Now, the facilities guy can pop 1 ceiling tile and access 2 pieces of equipment in one location. All right, with that placement set, I'm going to connect my terminal units to my mains. All right, my fourth and final step is to run branches or low pressure supply to the outlets. Guideline 4.1 is to minimize fittings. Fittings are expensive. Here's an example of what not to do. We've got 1, 2, 3, 4 fittings before we even get to any flex duct connecting to our diffusers. Here's a layout that minimizes fittings. In this one, we've got 1 Y fitting here, and then from there, you can just go to flex duct and connect straight to your diffuser. Guideline 4.2 is avoid U-turns or really harsh fittings. Here's a bad example. We've got a U-turn here. This is a very harsh fitting, a hard T. This goes back to the city street analogy. Imagine that you are Stuart Little in a little car and you have to drive through this ductwork. You can take 45-degree smooth turns a lot faster, but if you're coming up on a hard 90 like this, you either have to hit the brakes or you're going to hit a curb, and that's pressure loss, baby. Here's a good example. Fewer fittings, smoother turns. It'd be much easier to drive through this duct than the previous one. Guideline 4.3, and my final tip, is notice backtracking. Now, some backtracking is inevitable and acceptable, but if you find yourself backtracking a lot, that's a sign that your terminal units or your mains could be placed better. As I draw my ductwork here, you'll notice there's a little bit of backtracking as I go to serve this diffuser. That's acceptable. Let's say you have something like this, where this terminal unit is going back to serve these diffusers. When you see something like this, it should make you go, hey, wait a second. Maybe I can just move this down here and save some ductwork. So there you have it. That's my 4-step process for laying out a duct design, along with 9 practical guidelines for doing so. And go check out that video from April 3rd, and you'll see the diffuser guidelines.